This is SpaceTime Series 25, Episode 80. Coming up on SpaceTime, NASA's Curiosity rover goes into emergency safe mode on Mars, claims the Earth's mantle has two different compositions, and China slams NASA's claims that Beijing is militarizing the moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Curiosity rover has suddenly gone into emergency safe mode on the red planet after unusually high temperature spikes were detected in a key instrument control unit. Although Curiosity exited safe mode and was returned to normal operations 2 days later, mission managers are still analyzing the issue to try and determine the exact problem. For now, they suspect safe mode was triggered after a temperature sensor provided an inaccurate measurement. There's no sign that it will significantly affect the operations of the rover, since backup temperature measurements can ensure that electronics inside the rover don't get overheated. The six-wheel car-sized rover's been exploring the red planet scale crater ever since it touched down there 10 years ago, and it would appear the rover's starting to show its age. Its primary mission was to determine if Mars was ever capable of providing a habitable environment for life. And it quickly confirmed that Gale Crater was once a warm, wet world with flowing water and one capable of sustaining life, if it ever existed on Mars. The mission's also studying the Martian geology and climate. It's now gone on to try and understand how Mars has transitioned into the freeze-dried desert it is today. For the past year, Curiosity has been travelling through a transition zone. While the science team targeted the clay-rich region and the sulfate-laden one for evidence each can offer about the red planet's watery past, the transition zone is proving to be scientifically fascinating as well. In fact, this transition may provide the record of the major shift in Mars's climate billions of years ago that scientists are just beginning to understand. You see, the clay minerals formed when lakes and streams once rippled across Gale Crater, depositing sediment at what is now the base of Mount Sharp, 5-kilometre tall mountain at the centre of Gale Crater, whose foothills Curiosity's been ascending since 2014. Higher on the mountain in the transition zone, Curiosity's observations showed that the streams dried into trickles and sand dunes formed above the lake's sediments. Curiosity's project scientist Ashwin Vasavada from NASA's Jet Propulsion Laboratory in Pasadena, California, says the data shows there are no longer any of the lake deposits that were seen for years lower in Mount Sharp. Instead, there's evidence of drier climates, like dry dunes that occasionally had streams running around them, which you gotta admit's a big change from the lakes that persisted for millions of years before. And as the rover climbs higher through the transition zone, it's detecting less and less clay and more sulfate. Curiosity will soon be drilling the very last rock sample it will take in this zone, providing a more detailed glimpse of the changing mineral composition of these rocks. Unique geological features also stand out in this zone. The hills in this area likely began in a dry environment of large windswept sand dunes hardening into rock over time. Interspersed in the remains of these dunes are other sediments carried by water. These sediments now appear as erosion-resistant stacks of flaky layers. Making the story even richer yet more complicated is the knowledge that there were multiple periods in which groundwater ebbed and flowed over time. And that's left a jumble of puzzle pieces for Curiosity's mission managers to assemble into an accurate timeline. Although Curiosity has exited safe mode and has now returned to normal operations, mission managers are monitoring the rover closely. They've already found that its alloy wheels are showing signs of wear and tear after engineering teams commanded Curiosity to take new images of the wheels, something it's been doing every kilometre or so of travel distance just to check out their overall health. They found that the left middle wheel had damaged one of its grousers, the zigzag-like treads along Curiosity's wheels. Now, this particular wheel already had 4 broken grouses. The previously damaged grouses attracted attention recently because some of the metal skin between them appears to have fallen out of the wheel in recent months, leaving a gap. Mission managers have now decided to increase wheel imaging to every 500 metres, that's every half a kilometre of travel distance. Previous testing's already shown that Curiosity could drive safely on its wheel rims without any tread, that is, if it ever reached a point where a single wheel had broken the majority of its grouses. And the Martian environment isn't just playing havoc with the issue of Curiosity. Dust and grit are proving to be a problem with equipment all over Mars, with winds blowing grains of sand and dirt into delicate equipment and no people there to brush it out. And as this report from NASA TV explains, the view from orbit tells the story.
We're here at NASA's Jet Propulsion Laboratory in the Space Flight Operations Facility, also known as the Dark Room. This is where engineers send commands and receive data from JPL missions, including NASA's Mars Reconnaissance Orbiter. Now, detailed images from the orbiter are helping scientists better understand Martian winds. Leslie Tampery is MRO's Deputy Project Scientist. Leslie, what are we seeing in these images?
So what you can see here are dark patches on the surface of the ice near the South Polar region, and they're created by gas jets that come from under that ice up through cracks and deliver that dust out onto the ice. And the wind will carry that dust and lay it on the surface, forming these fans. And what we can do with this information is we can look at the directions and the sizes, and we can try to understand what the wind field is doing.
And I understand that volunteers played a large role in this research.
Yes, they did. We have taken about 75,000 images over all of Mars with our MRO high-rise camera. We used citizen scientists, 80,000 volunteers, to map these fans and map their directions and sizes.
Why is it important to study wind direction on Mars?
Some of our landers and rovers have had wind measurements, but only in a few locations at a few different times. But winds are very important for understanding today's climate on Mars, but also for trying to understand how the climate was different in the past. We also have huge dust storms that occur on Mars sometimes. But we don't understand why some storms become global and some don't. So we're trying to understand the wind field to try to put all these pieces together to understand Mars better.
And how does that information help protect NASA's spacecraft?
Right, it's very important for not only the spacecraft, but probably future human exploration as well. Because dust, it can be dangerous to hardware. For example, on the Perseverance rover, we're fortunate enough to have a wind sensor, and we're measuring dust devils. A couple of these dust devils and wind events were so large, they picked up not only dust, but bigger particles, sand-sized particles. And in fact, some of the wind sensors were damaged on the Perseverance rover. In other locations, we see hardly any dust devils. For example, the InSight lander has solar panels. The solar panels are completely covered with dust, and so the power is waning, and we'd really like to see some dust devils coming by so that they could clean off those solar panels and provide InSight with some more power. So learning about the winds and the different environments and how they change across Mars will really help us plan not only for the conditions for today's spacecraft there, but also plan better for the future. Winds on Mars can both help and hurt spacecraft. So we're getting really creative in how to study winds on the surface of Mars over a large region.
Thank you, Leslie.
This is SpaceTime. Still to come, claims the Earth's mantle is 2 different compositions, or at least it did at the start, and China slams NASA over claims about Beijing militarizing the moon. All that and more still to come on SpaceTime. A new study claims the Earth's mantle had a very different composition early in the planet's history, with the lower mantle nearest the outer core far drier than the upper mantle nearest the crust. The findings, reported in the Proceedings of the National Academy of Sciences, PNAS, challenged the once widely held assumption that Earth's mantle was uniform from the start. The Earth's mantle is the thick layer of silicate rock between the Earth's crust and its molten outer core. It makes up about 84% of the planet's entire volume. The mantle is predominantly solid, but on geologic timescales, it behaves more like a viscous fluid, as difficult to stir and mix as a pot of caramel. The new study suggests that the deep part of the ancient mantle, that closest to the Earth's molten outer core, started out substantially drier than the part of the mantle closest to the young planet's surface. By analysing noble gas isotope data, the authors have determined that the ancient plume mantle, that's the deepest part, had a water concentration that was a factor of 4 to 250 times lower when compared with the water concentration in the upper mantle. The resulting viscosity contrast could have prevented mixing within the mantle, hoping to explain certain long-standing mysteries about Earth's formation and evolution. The study's lead author, Rita Pari from Washington University in St. Louis, says the primordial viscosity contrast may explain why the giant impacts from space, which triggered whole mantle magma oceans, still didn't homogenize the growing planet. Pari undertook the experimental work with rock samples at her high-energy isotope geochemical laboratory. She studied noble gas isotopes, especially xenon, in volcanic rocks to understand the evolution of Earth's mantle composition, and in terrestrial rocks at the Earth's surface to see the evolution of the atmosphere. She says her findings could also explain why the plume mantle, that's the really deep mantle near the Earth's core, has experienced less processing by partial melting over Earth history. When the solar system settled into its current layout around 4.5 billion years ago, Earth formed when gravity pulled in swirling gas and condensing dust, eventually producing the third rock from the Sun. Volatiles like water, carbon, nitrogen, and the noble gases were delivered as the Earth formed. But Pari's study suggested the material that accreted earlier was a drier type of rock from that which accreted later. She found that mantle helium, neon and xenon isotopes required that the plume mantle had lower concentrations of volatiles like xenon and water at the end of the period of accretion, compared to the upper mantle. She says the upper mantle may well have benefited from a larger contribution of mass from volatile-rich materials, similar to meteorites known as carbonaceous chondrites. And of course, let's not forget the Theia impact, which created the Moon. That involved a body the size of Mars, which also slammed into the Earth around 4.5 billion years ago. That impact also turned the Earth's surface into a magma ocean, with some of the ejected debris entering orbit around the forming planet to eventually solidify and create the Moon. This is SpaceTime. Still to come, China slams NASA's boss over claims that Beijing is militarizing the Moon, and later in the science report, the growing threat posed by the monkeypox virus. All that and more still to come on SpaceTime. Beijing has slammed claims by NASA Administrator Bill Nelson that China is trying to gain the ultimate high ground by militarizing the Moon. Nelson told the German news magazine Der Bild that the West should be very concerned that China's landing on the Moon and saying things like it's ours now, you stay out. Nelson's also pointed out the fact that China's developed the capacity to destroy spacecraft in orbit, including those of other nations. The warnings come as Beijing continues to significantly ramp up its space program amid repeated calls by the Chinese President Xi Jinping for the People's Liberation Army to prepare for war. China and Russia recently signed an agreement to develop a permanent joint base on the Moon's south pole by 2026. China's Foreign Ministry spokesman Zhao Lijian says the claims by NASA's chief are reckless falsehoods. Legally, any attempt by China to take over the Moon would be considered a violation of international space law. The Outer Space Treaty, adopted in 1967 and signed by 134 countries, including China, explicitly states that outer space, including the Moon and other celestial bodies, is not subject to national appropriation by claim of sovereignty, by means of use or occupation, or by any other means. Of course, the law hasn't stopped China building a bunch of military bases in the disputed Spratly Islands in order to flagrantly violate international law and claim ownership of the entire South China Sea, saying it's Beijing's exclusive economic zone. In response to that, the United States, Australia, Canada and the British Royal Navy routinely undertake what they call freedom of navigation operations through the area. If the purpose of these operations are to annoy Beijing, they hit a home run. Meanwhile, China's launched another Gaofen high-resolution spy satellite. The Gaofen 1203 was launched aboard a Long March 4C rocket from the Zhuquan Satellite Launch Center in northwestern China. The spacecraft was placed into a near-polar orbit at an average altitude of 628 kilometers. Beijing describes the satellite as a microwave remote sensing spacecraft designed to monitor crop yields, land surveys, urban planning, road network design, and disaster relief. In reality, it's a high-resolution reconnaissance surveillance satellite being operated on behalf of the People's Liberation Army with a microwave remote sensing radar system and ground resolution down to the sub-meter level. That's not commonly needed to measure crop yields, but it is great for identifying enemy missile batteries and troop numbers under all weather conditions, day and night. Since 2016, Beijing has launched more than 191 Earth observation, surveillance or reconnaissance satellites. That includes at least 41 Gaofen and some 92 Yaogang spy satellites designed to provide near-continuous high-resolution and electronic monitoring of areas of interest to China. Virgin Orbit has successfully launched 7 United States Space Force satellites aboard a Launcher One carrier rocket, which was dropped from the specially modified Boeing 747 airliner Cosmic Girl. The nighttime flight, called Straight Up, took off from the Mojave Air and Spaceport in California. Launcher One was released from Cosmic Girl high over the North Pacific Ocean and then carried its payload up to an altitude of around 500 kilometers before deploying all 7 satellites. The spacecraft are from multiple US government agencies and are designed to undertake a range of scientific experiments demonstrating new spacecraft technologies, new approaches to satellite applications, and Earth atmospheric science. Virgin Orbit's now preparing for their first international launch, Prometheus 2. That'll be a joint mission between the United Kingdom Space Agency, the British Royal Air Force, and the United States National Reconnaissance Office. The flight will take off from Spaceport Cornwall in the UK, marking the first ever orbital mission to fly from British soil. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.